Welcome, everyone, to tonight's exploration of the intricate dance of systems dynamics and chaos, specifically as it manifests in the very air we breathe, the weather. As we settle in, let's gently unravel the layers of complexity that govern our atmosphere, revealing how seemingly insignificant events can cascade into dramatic, unpredictable patterns. Imagine the atmosphere as a vast, interconnected web, where every gust of wind, every drop of rain, and every molecule of water vapor plays a role in a symphony of perpetual motion. This symphony, however, is not always harmonious. It's often characterized by turbulence, sudden shifts, and unexpected crescendos, all driven by the underlying principles of chaos theory and systems dynamics. To begin, let's ground ourselves in the fundamentals. Systems dynamics, at its core, is a methodology for understanding how complex systems change over time. It emphasizes the interconnectedness of various elements within a system and how feedback loops, both positive and negative, influence the overall behavior. In the context of weather, this means considering the myriad factors that interact to shape our atmospheric conditions. Temperature, pressure, humidity, solar radiation, and countless others. These factors are not isolated. They constantly influence one another, creating a dynamic web of cause and effect. Now, let's introduce the concept of chaos theory, a subset of systems dynamics that deals with systems highly sensitive to initial conditions. You've likely heard of the butterfly effect, a popular metaphor for this sensitivity. It suggests that the flapping of a butterfly's wings in Brazil could, theoretically, set off a chain of events that culminates in a tornado in Texas. While this is a dramatic illustration, it captures the essence of chaotic systems. Tiny changes in initial conditions can lead to vastly different outcomes. In weather models, this sensitivity poses a significant challenge. These models are sophisticated computer simulations that attempt to predict future weather conditions based on current observations. They incorporate vast amounts of data, including temperature readings from weather stations, satellite imagery, and wind patterns. However, even with the most advanced technology, there's always a degree of uncertainty in the initial conditions. We can never know the state of the atmosphere with perfect precision. And because of the butterfly effect, even small errors in these initial conditions can amplify over time, leading to significant deviations in the model's predictions. Think of it like trying to predict the path of a leaf falling in a turbulent stream. You might be able to estimate its general direction, but the exact twists and turns it takes are virtually impossible to foresee. To truly grasp the implications of chaos in weather systems, it's helpful to consider a specific example: the formation of a thunderstorm. Thunderstorms are born from a complex interplay of atmospheric conditions, including warm, moist air near the surface, a source of lift, such as a front or a mountain range, and instability in the atmosphere. These conditions create an environment where air parcels can rise rapidly, cool, and condense, forming towering cumulonimbus clouds. However, the precise timing and location of thunderstorm development are incredibly sensitive to small-scale variations in temperature and humidity. A slight increase in surface temperature, a subtle shift in wind direction, or even a localized patch of dry air can be the difference between a sunny afternoon and a severe thunderstorm. These small variations act as the butterfly wings that trigger or suppress thunderstorm formation. Another fascinating aspect of chaotic weather systems is the emergence of self-organized patterns. Think about the swirling vortices of a hurricane or the intricate branching patterns of a lightning strike. These patterns arise spontaneously from the interactions of countless individual elements: air molecules, water droplets, and electrical charges, without any central control or external direction. It's as if the system is organizing itself, finding stable configurations that dissipate energy efficiently. This phenomenon is known as self-organized criticality, and it's a hallmark of chaotic systems. The system hovers near a critical point where small perturbations can trigger large-scale events. Imagine a sand pile. As you add grains of sand one by one, the pile grows taller and steeper until it reaches a point where adding just one more grain causes a landslide. The atmosphere is similar. It's constantly accumulating energy and instability until it reaches a critical point where a small trigger can unleash a powerful weather event. The implications of chaos theory for weather forecasting are profound. It means that there are inherent limits to predictability. We can never hope to predict the weather with perfect accuracy beyond a certain time horizon, typically about 2 weeks. This is not a reflection of our technological limitations. It's a fundamental property of the system itself. However, this doesn't mean that weather forecasting is futile. While we can't predict the exact weather on a specific day months in advance, we can still make probabilistic forecasts that provide valuable information about the likelihood of different weather scenarios. For example, we might say that there's a 70% chance of above average temperatures next summer, or that there's a 30% chance of a major hurricane making landfall along the Gulf Coast. These probabilistic forecasts are based on our understanding of the underlying dynamics of the climate system and the statistical properties of chaotic systems. To improve weather forecasts, scientists are constantly working to refine weather models and incorporate more data. One promising approach is ensemble forecasting, which involves running multiple versions of a weather model with slightly different initial conditions. By comparing the results of these different simulations, we can get a sense of the range of possible outcomes and the uncertainty associated with a forecast. Another important area of research is data assimilation, which involves combining observations from various sources, weather stations, satellites, and radar, to create a more accurate picture of the current state of the atmosphere. This improved initial condition can then be used to initialize weather models and produce more reliable forecasts. Furthermore, advancements in computing power allow for higher resolution models, which can capture smaller scale features of the atmosphere and improve the accuracy of local weather forecasts. Imagine being able to predict the exact location and intensity of a rain shower in your neighborhood, or the precise timing of a frost event in your garden. These are the kinds of improvements that are becoming increasingly possible with advances in weather modeling technology. Beyond forecasting, The study of chaos in weather systems has broader implications for our understanding of climate change. Climate models, which are used to project future climate scenarios, are also subject to the limitations of chaos theory. This means that there's inherent uncertainty in climate projections, especially when it comes to regional scale changes. However, climate models can still provide valuable insights into the long-term trends and patterns of climate change. By simulating the effects of greenhouse gas emissions on the Earth's energy balance, we can estimate the likely range of future temperature increases, sea level rise, and other climate impacts. These projections are essential for informing policy decisions and planning for the future. Understanding the role of feedback loops in the climate system is particularly important. For example, the melting of Arctic sea ice reduces the Earth's reflectivity, causing more solar radiation to be absorbed and leading to further warming. This is a positive feedback loop that amplifies the effects of climate change. Conversely, increased cloud cover can reflect more sunlight back into space, cooling the planet. This is a negative feedback loop that dampens the effects of climate change. The interplay of these feedback loops determines the overall sensitivity of the climate system to greenhouse gas emissions. Now, let's delve deeper into the fascinating world of feedback loops and their profound influence on weather patterns. Imagine a thermostat in your home. When the temperature drops below a certain point, the thermostat triggers the heating system to turn on, raising the temperature. Once the desired temperature is reached, the thermostat shuts off the heating system, preventing the temperature from rising too high. This is an example of a negative feedback loop, which helps to stabilize the system and maintain equilibrium. In weather systems, negative feedback loops can dampen oscillations and prevent runaway effects. For example, as a thunderstorm grows, it eventually starts to produce downdrafts that cool the air near the surface, suppressing further updrafts and limiting the storm's growth. This negative feedback loop helps to prevent thunderstorms from becoming too intense. Positive feedback loops, on the other hand, amplify changes and can lead to instability. Consider the example of sea ice melt. As temperatures rise, sea ice begins to melt, exposing darker ocean water. Darker surfaces absorb more solar radiation than lighter surfaces, causing the ocean to warm further. This warmer water then melts more sea ice, creating a positive feedback loop that accelerates the melting process. In weather systems, positive feedback loops can trigger extreme events and abrupt shifts in climate. For example, during a drought, dry soil reflects more sunlight back into the atmosphere, reducing cloud formation and rainfall. This lack of rainfall further dries out the soil, creating a positive feedback loop that intensifies the drought. Understanding these feedback loops is crucial for predicting how weather patterns will respond to climate change. Another key concept in understanding weather dynamics is the idea of teleconnections. Teleconnections are long-distance relationships between weather patterns in different parts of the world. For example, the El Niño Southern Oscillation, YNSO, is a teleconnection that links sea surface temperatures in the tropical Pacific Ocean to weather patterns across the globe. During an El Niño event, warmer than average waters in the eastern Pacific can lead to increased rainfall in the southwestern United States and drier conditions in Australia and Indonesia. Conversely, during a La Nina event, cooler than average waters in the eastern Pacific can lead to drier conditions in the southwestern United States and wetter conditions in Australia and Indonesia. These teleconnections are caused by changes in atmospheric circulation patterns that propagate across long distances. Understanding teleconnections can help us to predict weather patterns months or even seasons in advance. For example, if we know that an El Niño event is developing, we can anticipate the likely impacts on rainfall and temperature in different regions of the world. Now, let's explore the role of clouds in regulating Earth's climate. Clouds are a crucial component of the climate system, influencing both the amount of solar radiation that reaches the surface and the amount of heat that escapes into space. Low-level clouds, such as stratus and cumulus clouds, are very effective at reflecting sunlight back into space, cooling the planet. High-level clouds, such as cirrus clouds, are less effective at reflecting sunlight, but are very effective at trapping heat, warming the planet. The net effect of clouds on climate is complex and depends on the type, altitude, and distribution of clouds. Climate models struggle to accurately represent clouds, which is a major source of uncertainty in climate projections. Small changes in cloud cover can have a significant impact on global temperatures. For example, a decrease in low-level cloud cover could lead to a significant warming of the planet. Scientists are working to improve our understanding of clouds and their role in climate regulation. Let's now consider the role of oceans in influencing weather patterns. Oceans cover about 70% of Earth's surface and have a much higher heat capacity than land. This means that oceans can absorb and store vast amounts of heat, moderating Earth's climate. Ocean currents transport heat from the equator towards the poles, redistributing energy around the planet. The Gulf Stream, for example, is a warm ocean current that originates in the Gulf of Mexico and flows northward along the eastern coast of the United States, warming Western Europe. Changes in ocean currents can have a significant impact on weather patterns. For example, a slowdown in the Atlantic Meridional Overturning Circulation, AMOC, a major ocean current system in the Atlantic Ocean, could lead to colder winters in Europe and North America. Oceans also play a crucial role in the carbon cycle, absorbing about 30% of the carbon dioxide emitted by human activities. However, as oceans absorb more carbon dioxide, they become more acidic, which can have harmful effects on marine life. Understanding the interactions between oceans and the atmosphere is essential for predicting weather patterns and climate change. Now, let's examine the impact of human activities on weather patterns. Human activities, such as burning fossil fuels, deforestation, and agriculture, are altering the composition of the atmosphere and changing Earth's climate. The burning of fossil fuels releases greenhouse gases, such as carbon dioxide, into the atmosphere, trapping heat and warming the planet. Deforestation reduces the amount of carbon dioxide absorbed by plants, further increasing the concentration of greenhouse gases in the atmosphere. Agriculture releases methane, another potent greenhouse gas, into the atmosphere. These changes in atmospheric composition are leading to changes in weather patterns, including more frequent and intense heat waves, droughts, floods, and storms. Climate change is also causing sea levels to rise, threatening coastal communities. Reducing greenhouse gas emissions is essential for mitigating the impacts of climate change on weather patterns. The relationship between climate change and extreme weather events is a complex and actively researched area of climate science. While it's difficult to attribute any single weather event solely to climate change, scientists can analyze trends and determine how climate change is influencing the frequency and intensity of these events. For example, warmer temperatures lead to more evaporation, which can fuel stronger storms and increase the risk of heavy precipitation and flooding. Changes in atmospheric circulation patterns can also contribute to prolonged droughts in some regions, while other areas experience more frequent and intense heat waves. The melting of glaciers and ice sheets contributes to sea level rise, making coastal communities more vulnerable to storm surges and flooding. Understanding these connections is crucial for developing effective strategies for adapting to the impacts of climate change and mitigating future risks. Another vital aspect of understanding unpredictable weather patterns lies in the study of feedback loops within a climate system. Feedback loops can amplify or dampen the effects of initial changes, leading to complex and sometimes unexpected consequences. A positive feedback loop, for instance, enhances the initial change. Consider the melting of Arctic sea ice. As the ice melts, it exposes darker ocean water, which absorbs more solar radiation than the reflective ice. This increased absorption of solar energy warms the ocean further, leading to even more ice melt. This cycle continues, accelerating the warming process in the Arctic. Conversely, a negative feedback loop diminishes the initial change. An example is the increase in cloud cover due to increased evaporation. Clouds can reflect incoming solar radiation, reducing the amount of energy absorbed by the Earth and thus cooling the planet. However, the effect of clouds on climate is complex, as they can also trap heat, leading to warming. The interplay of these positive and negative feedback loops makes predicting the long-term consequences of climate change a challenging task. The predictability of weather patterns is also inherently limited by the chaotic nature of the atmosphere. The butterfly effect, a concept closely associated with chaos theory, illustrates this limitation. It suggests that even a tiny change in initial conditions, such as the flap of a butterfly's wings, can have a significant and unpredictable impact on the weather in the long run. This is because the atmosphere is a highly sensitive system, where small disturbances can amplify over time, leading to large-scale changes. Weather models are based on mathematical equations that describe the behavior of the atmosphere, but even the most sophisticated models cannot perfectly capture all the complexities and uncertainties of the real world. As a result, weather forecasts become less accurate the further into the future they predict. While short-term forecasts, such as those for the next few days, can be quite reliable, predicting weather patterns weeks or months in advance is much more challenging. Furthermore, Understanding weather patterns requires considering the influence of various natural climate oscillations. These oscillations are recurring patterns of climate variability that can last for months, years, or even decades. The El Niño Southern Oscillation, ENSO, for example, is a periodic fluctuation in sea surface temperatures and atmospheric pressure in the tropical Pacific Ocean. El Niño events, characterized by warmer than average sea surface temperatures in the central and eastern Pacific, can have significant impacts on weather patterns around the world, leading to increased rainfall in some regions and droughts in others. La Niña events, characterized by cooler than average sea surface temperatures, can have opposite effects. Other important climate oscillations include the Pacific Decadal Oscillation, PDO, and the North Atlantic Oscillation, NAO, which can influence weather patterns in the North Pacific and North Atlantic regions, respectively. These oscillations can interact with each other and with climate change, further complicating the prediction of weather patterns. Finally, it's important to remember that our understanding of weather patterns and climate change is constantly evolving as scientists gather more data and develop more sophisticated models. Satellite observations, ground-based measurements, and computer simulations are all essential tools for studying the climate system and improving our ability to predict future weather patterns. International collaborations, such as the Intergovernmental Panel on Climate Change, IPCC, play a crucial role in assessing the state of climate science and providing policymakers with the information they need to make informed decisions about climate change mitigation and adaptation. By continuing to invest in research and monitoring efforts, we can gain a deeper understanding of the complex interactions that shape our weather and climate, and better prepare ourselves for the challenges and opportunities that lie ahead. So, as you drift off to sleep, consider the intricate dance of air, water, and energy that shapes the world around us, and the ongoing quest to unravel its mysteries. Good night. The beauty of these complex systems and the reason they lend themselves so well to the study of chaos and unpredictability lies in their interconnectedness. Imagine a vast, invisible web stretching across the globe, where every tug in one corner reverberates, however subtly, throughout the entire structure. The ocean currents, for instance, are not just isolated rivers of water. They're intricately linked to atmospheric circulation, transferring heat and moisture across vast distances. The Gulf Stream, a warm and swift Atlantic current originating in the Gulf of Mexico, plays a crucial role in moderating the climate of Western Europe, keeping it significantly warmer than other regions at similar latitudes. Changes in the strength or path of the Gulf Stream, potentially influenced by melting glaciers or shifts in atmosphere pressure, could have profound consequences for European weather patterns. Similarly, the Amazon rainforest, often referred to as the lungs of the planet, plays a vital role in regulating global climate. Through the process of transpiration, trees release vast amounts of water vapor into the atmosphere, which then forms clouds and contributes to rainfall patterns. Deforestation, on the other hand, reduces transpiration, leading to drier conditions and potentially impacting rainfall not only in the Amazon region, but also in distant areas. This interconnectedness highlights the importance of considering the entire Earth system when studying weather and climate, as changes in one component can trigger a cascade of effects that are difficult to predict with certainty. Furthermore, the Earth's climate system is subject to various feedback loops, which can amplify or dampen initial changes. A positive feedback loop reinforces the initial change, leading to further warming or cooling. For example, as temperatures rise, ice and snow melt, reducing the Earth's albedo, reflectivity, and causing the planet to absorb more solar radiation, leading to further warming. A negative feedback loop, on the other hand, counteracts the initial change, helping to stabilize the system. For example, as temperatures rise, evaporation increases, leading to more cloud formation, which can reflect sunlight back into space and cool the planet. The interplay of these positive and negative feedback loops determines the overall sensitivity of the climate system to changes in greenhouse gas concentrations and other factors. The challenge of predicting weather and climate is further compounded by the inherent limitations of our models. While climate models have become increasingly sophisticated over the years, they're still simplifications of the real world. They rely on mathematical equations to represent the complex physical processes that govern the climate system. But these equations are often based on approximations and assumptions. Moreover, climate models are limited by the availability and accuracy of observational data. There are still many gaps in our understanding of the climate system, particularly at regional and local scales. For instance, predicting the precise location and intensity of future hurricanes remains a significant challenge due to the complex interactions between the atmosphere, ocean, and land surface. Despite these challenges, scientists are making significant progress in improving our understanding of weather and climate. By combining advanced modeling techniques with vast amounts of observational data, they are able to make increasingly accurate predictions of future weather patterns and climate change. The development of ensemble forecasting, which involves running multiple simulations of a climate model with slightly different initial conditions, has also helped to improve the reliability of forecasts. By analyzing the range of possible outcomes from the ensemble, scientists can better assess the uncertainty associated with their predictions and provide more robust information to policymakers and the public. So, let your mind wander through the complexities of our atmosphere, the push and pull of ocean currents, and the delicate balance of our planet as you peacefully fall asleep. Sweet dreams. And as you drift off, consider the fascinating field of chaos theory and its profound implications for weather prediction. Chaos theory, at its core, suggests that even in deterministic systems governed by fixed rules, seemingly insignificant variations in initial conditions can lead to drastically different outcomes. This is often referred to as the butterfly effect, where the flapping of a butterfly's wings in Brazil could theoretically set off a tornado in Texas. While the analogy is somewhat simplistic, it illustrates the point that the atmosphere is incredibly sensitive to even the smallest disturbances. These disturbances can arise from a multitude of sources, for variations in solar radiation to changes in surface temperatures. As these disturbances propagate and interact with each other, they can amplify or dampen, leading to complex and unpredictable weather patterns. Think of it like a river flowing downstream. A small pebble dropped into the water might cause a ripple that expands and eventually dissipates. However, if that pebble is dropped into a particularly turbulent part of the river, it could trigger a cascade of events that significantly alters the flow downstream. Similarly, small changes in atmospheric conditions can trigger a chain reaction that leads to large-scale weather phenomena. This inherent sensitivity to initial conditions makes long-term weather prediction exceedingly difficult. Even with the most advanced models and vast amounts of data, there will always be a degree of uncertainty in our forecasts. This uncertainty doesn't mean that weather prediction is impossible, however. Rather, it highlights the importance of understanding the limitations of our models and a need for continuous improvement. Scientists are constantly working to refine their understanding of the climate system and develop more sophisticated models that can capture the complex interactions between different components. They are also exploring new techniques for data assimilation, which involves incorporating observational data into models to improve their accuracy. Furthermore, the development of artificial intelligence and machine learning offers promising avenues for improving weather prediction. These techniques can be used to identify patterns in large data sets and develop more accurate statistical models of weather phenomena. So, as you close your eyes, imagine the intricate dance of air molecules, the swirling of clouds, and the relentless energy of the sun. Picture the complex interplay of forces that shapes our weather and climate, and marvel at the ingenuity of scientists who are striving to unravel its secrets. Remember that even in the face of uncertainty, progress is being made, and our understanding of the world around us is constantly evolving. Let the gentle rhythm of these thoughts lull you into a peaceful slumber, knowing that the mysteries of the universe are always waiting to be explored. Sleep well, and as you drift off, consider the concept of ensemble forecasting. Instead of relying on a single weather model run, meteorologists often use multiple models, each starting with slightly different initial conditions or using different parameterizations of physical processes. By comparing the results of these different models, they can get a sense of the range of possible outcomes and assess the uncertainty associated with their forecasts. Think of it like running the river analogy multiple times, each time dropping the pebble in a slightly different spot. Some runs might show minimal impact downstream, while others might reveal significant alterations in the flow. This ensemble approach allows forecasters to provide probabilistic forecasts, which give you the likelihood of different weather scenarios occurring. Instead of saying, "It will definitely rain tomorrow," they could say there is an 80% chance of rain tomorrow. This probabilistic approach acknowledges the inherent uncertainty in weather prediction and provides more useful information for decision-making. Furthermore, it's important to appreciate the sheer scale and complexity of the climate system. The atmosphere is not an isolated entity. but rather a complex network of interacting components, including the oceans, land surface, ice sheets, and biosphere. These components exchange energy and momentum, influencing each other in intricate ways. For example, changes in ocean temperatures can affect atmospheric circulation patterns, which in turn can influence precipitation patterns over land. Similarly, melting ice sheets can alter sea levels and ocean salinity, which can have far-reaching consequences for the climate system. Understanding these complex interactions is crucial for improving our ability to predict weather and climate. Scientists are constantly working to develop more comprehensive models that capture these interactions more accurately. These models are often run on supercomputers, which allow them to simulate the climate system at high resolution and with greater detail. Think about the humble water cycle: evaporation, condensation, precipitation. It seems simple enough, but when you consider the global scale and the influence of factors like wind patterns, land elevation, and vegetation cover, it becomes incredibly complex. The amount of water vapor in the atmosphere, even in small variations, can dramatically affect temperature and precipitation. These subtle changes, amplified through feedback loops, can lead to significant shifts in weather patterns. For example, increased evaporation can lead to more cloud cover, which can reflect sunlight back into space, cooling the planet. However, clouds can also trap heat, leading to warming. The net effect of clouds on the climate is still an area of active research. As you relax, let your mind wander to the fascinating world of atmospheric waves. Just as the ocean has waves, so too does the atmosphere. These waves can travel vast distances and play a crucial role in transporting energy and momentum around the globe. Some atmospheric waves, known as Rossby waves, are particularly important for weather patterns in the mid-latitudes. These waves are large-scale meanders in the jet stream, a fast-flowing current of air that circles the globe. Rossby waves can influence the location of high and low-pressure systems, which in turn affect temperature and precipitation patterns. Understanding the behavior of atmospheric waves is essential for predicting weather patterns on a timescale of days to weeks. And finally, remember that the study of weather and climate is not just an academic pursuit. It has profound implications for society, affecting everything from agriculture and energy production to public health and disaster preparedness. Accurate weather forecasts can help farmers make informed decisions about planting and harvesting, allowing them to maximize their yields and minimize their losses. Reliable climate projections can help policymakers develop strategies for adapting to the impacts of climate change, such as rising sea levels and more frequent extreme weather events. By investing in weather and climate research, we can improve our ability to understand and respond to the challenges facing our planet. So, rest easy knowing that dedicated scientists are working tirelessly to unlock the secrets of the atmosphere and create a more sustainable future for all. Sweet dreams. Now, let's gently shift our focus to the phenomenon of weather fronts. Imagine the atmosphere as a giant, swirling canvas, where masses of air with different temperatures and humidities are constantly colliding and interacting. A weather front is essentially the boundary between two of these air masses. When a cold air mass pushes under a warmer air mass, we call it a cold front. These fronts are often associated with rapid temperature drops, strong winds, and heavy precipitation, sometimes even thunderstorms. On the other hand, when a warm air mass rides up and over a colder air mass, it's known as a warm front. Warm fronts typically bring more gradual changes in temperature and are often accompanied by widespread, light to moderate rain or snow. The interaction of these fronts, their speed, and their intensity are all governed by complex atmospheric dynamics, making accurate prediction a significant challenge for meteorologists. Think about the role of geography too. Mountain ranges, coastlines, and even large bodies of water can have a profound impact on local and regional weather patterns. Mountains can force air to rise, leading to increased precipitation on the windward side and a drier rain shadow on the leeward side. The ocean acts as a massive heat reservoir, moderating coastal temperatures and influencing the formation of sea breezes and land breezes. These geographical features introduce additional layers of complexity into weather models, requiring sophisticated algorithms to capture their effects accurately. The interplay between these geographical factors and the broader atmospheric circulation creates a tapestry of diverse weather conditions across the globe. Consider also the impact of human activities on weather and climate. While natural variability plays a dominant role in short-term weather patterns, human-induced climate change is increasingly influencing long-term trends. The burning of fossil fuels releases greenhouse gases into the atmosphere, trapping heat and causing the planet to warm. This warming is leading to changes in precipitation patterns, more frequent and intense heat waves, and rising sea levels. Understanding the complex interactions between human activities and the climate system is crucial for mitigating the impacts of climate change and building a more sustainable future. Scientists are using sophisticated climate models to project future climate scenarios and assess the potential consequences of different policy choices. These models are constantly being refined and improved as our understanding of the climate system grows. And before you drift off to sleep, ponder the incredible advancements in weather forecasting technology. From weather balloons and satellites to supercomputers and sophisticated algorithms, meteorologists have a vast array of tools at their disposal. Weather satellites provide a continuous stream of data on temperature, humidity, and cloud cover, allowing forecasters to monitor atmospheric conditions in real time. Supercomputers are used to run complex weather models that simulate the behavior of the atmosphere. These models are constantly being updated with new data and improved algorithms, leading to more accurate and reliable forecasts. While weather forecasting is still not perfect, it has come a long way in recent decades, and continued advancements in technology promise to further improve our ability to predict the weather. So, close your eyes and let the thought of these technological marvels lull you into a peaceful slumber. May your dreams be filled with clear skies and gentle breezes. Good night. Now, as you settle in and prepare to drift off, let's consider the fascinating concept of feedback loops in weather systems. These loops, both positive and negative, play a critical role in amplifying or dampening changes in the atmosphere. A positive feedback loop is like a snowball rolling down a hill, getting bigger and faster as it goes. For example, as the Earth warms, ice melts, exposing darker surfaces that absorb more sunlight, leading to further warming. This, in turn, melts more ice, and the cycle continues. Negative feedback loops, on the other hand, act as stabilizers, counteracting changes and maintaining equilibrium. An example of a negative feedback loop is the increase in cloud cover as the Earth warms. Clouds can reflect sunlight back into space, reducing the amount of solar radiation absorbed by the Earth's surface and thus cooling the planet. The interplay between these positive and negative feedback loops determines the overall sensitivity of the climate system to changes in forcing factors, such as greenhouse gas emissions. Understanding these intricate feedback mechanisms is essential for accurately predicting future climate change scenarios and developing effective mitigation strategies. Think also about the role of oceans in weather patterns. Oceans cover more than 70% of the Earth's surface and have a tremendous capacity to store heat. This heat is slowly released back into the atmosphere, influencing regional and global weather patterns. Ocean currents, such as the Gulf Stream, transport warm water from the tropics towards the poles, moderating temperatures in Europe and other regions. The El Niño Southern Oscillation, YNSO, is a natural climate pattern that occurs in the tropical Pacific Ocean and has a significant impact on weather around the world. During El Niño events, warmer than average sea surface temperatures in the central and eastern Pacific can lead to increased rainfall in some regions and drought in others. La Niña events, which are characterized by cooler than average sea surface temperatures in the same region, can have the opposite effect. These oceanic oscillations are complex and influenced by a variety of factors, including atmospheric winds, ocean currents, and the Earth's rotation. Scientists are constantly working to improve their understanding of these processes and develop better forecasts of El Niño and La Niña events. And while the larger weather systems capture our attention, don't overlook the impact of local factors. The topography of the land, such as mountains and valleys, can have a significant influence on weather patterns. Mountains can force air to rise, leading to increased precipitation on the windward side and a rain shadow effect on the leeward side. Coastal regions experience different weather patterns than inland areas due to the moderating influence of the ocean. Urban areas also have their own unique microclimates, characterized by higher temperatures and altered wind patterns due to the presence of buildings, roads, and other infrastructure. Even small-scale features, such as forests and lakes, can have a measurable impact on local weather. Understanding these local factors is important for developing accurate weather forecasts and managing resources effectively. Consider how a forest might influence rainfall patterns in a small region, or how the presence of a large lake can moderate temperatures throughout the year. These subtle but important interactions contribute to the rich and complex tapestry of weather that we experience every day. So, as you continue to relax and let your mind wander, Think about the interconnectedness of all these elements, from the smallest atmospheric particles to the largest ocean currents. Everything is linked together in a delicate dance. The weather is a constantly evolving system, shaped by a multitude of factors that interact in complex and often unpredictable ways. But within this complexity lies a certain beauty and wonder. The next time you experience a change in the weather, take a moment to appreciate the intricate processes that are at play. Consider the forces that are shaping the atmosphere and influencing the world around you. And remember that even the smallest changes can have a ripple effect, leading to unexpected and sometimes dramatic consequences. Now, breathe deeply, let go of any remaining thoughts, and allow yourself to drift into a peaceful and restorative sleep. The mysteries of the weather will still be here when you wake up, waiting to be explored and understood. Sleep well. And as we drift further into this exploration of weather's fascinating unpredictability, let's consider the role of feedback loops. These loops, both positive and negative, are crucial in understanding how small changes can be amplified or dampened within the weather system. A positive feedback loop, for instance, might involve the melting of Arctic ice. As the ice melts due to warming temperatures, it exposes darker ocean water. This darker water absorbs more solar radiation than the reflective ice, leading to further warming and even more ice melt. This creates a self-reinforcing cycle that accelerates the initial change. On the other hand, a negative feedback loop might involve increased cloud cover. As temperatures rise, more water evaporates, leading to the formation of more clouds. These clouds can reflect sunlight back into space, reducing the amount of solar radiation that reaches the Earth's surface and thus cooling the planet. This acts as a stabilizing force, counteracting the initial warming trend. Understanding these feedback loops is essential for predicting how the weather system will respond to various changes and for developing strategies to mitigate the effects of climate change. Now, think about the atmosphere itself, a vast ocean of air constantly in motion. Within this ocean, there are currents and eddies, just like in the real ocean. Jet streams, for example, are high-altitude rivers of air that can steer weather systems across continents. These jet streams are influenced by temperature differences between the Arctic and the equator and can meander and shift, bringing unusual weather patterns to different regions. El Niño and La Niña are other examples of large-scale atmospheric and oceanic phenomena that can have a profound impact on global weather patterns. El Niño, characterized by warmer than average sea surface temperatures in the central and eastern Pacific Ocean, can lead to increased rainfall in some areas and droughts in others. La Niña, the opposite of El Niño, is characterized by cooler than average sea surface temperatures in the same region and can also have significant impacts on weather patterns around the world. These phenomena are complex and interconnected, and their behavior is still not fully understood, adding to the challenge of weather prediction. Consider, too, the influence of the sun, our ultimate source of energy. The amount of solar radiation that reaches the Earth varies throughout the year and is also affected by factors such as sunspots and solar flares. These variations can have a subtle but measurable impact on weather patterns. The Earth's orbit around the Sun is not perfectly circular, and this also leads to variations in the amount of solar radiation that reaches different parts of the planet at different times of the year. These astronomical factors, combined with the complex interactions within the atmosphere and oceans, contribute to the overall unpredictability of the weather. So, as you continue to relax, imagine the Earth as a giant, interconnected system, with energy flowing from the Sun through the atmosphere and oceans and back into space. Visualize the complex dance of molecules and particles, the interplay of forces and energies, and the constant evolution of weather patterns. Remember that even the smallest events can have far-reaching consequences, and that the weather is a reflection of the intricate and dynamic nature of our planet. Let these thoughts soothe you and guide you into a deeper state of relaxation. Allow yourself to be carried away by the gentle rhythm of your breath and the calming awareness of your body. Release any tension or worries that you may be holding onto, and simply be present in this moment. The weather will continue to unfold day after day, season after season, a testament to the beauty and complexity of the natural world. And you, too, are a part of this world, connected to everything around you. Now, let go and drift into sleep, knowing that you are safe, secure, and deeply connected to the universe. Sweet dreams. And as you drift further, consider the role of feedback loops in this vast system. Positive feedback loops can amplify a small change, leading to exponential growth, like a tiny snowball rolling down a hill, gathering more snow and becoming an avalanche. Imagine a small increase in temperature leading to more water vapor in the atmosphere. Water vapor is a greenhouse gas, so it traps more heat, leading to further warming and thus more water vapor. This is a positive feedback loop, amplifying the initial change. Conversely, negative feedback loops act to dampen changes and maintain stability. Think of clouds reflecting sunlight back into space. As the Earth warms, more clouds may form, reflecting more sunlight and cooling the planet. This is a negative feedback loop, counteracting the initial warming. These feedback loops, both positive and negative, are constantly interacting, creating a complex web of influences that shape our weather. Visualize now the concept of tipping points. These are thresholds beyond which a small change can trigger a large and often irreversible shift in the system. Imagine a glacier slowly melting over decades. As it melts, it exposes darker land or ocean underneath, which absorbs more sunlight, leading to further melting. Eventually, the glacier may reach a tipping point where the rate of melting accelerates dramatically, leading to its rapid disappearance. In the context of weather, a tipping point could be a shift in ocean currents, leading to a sudden and prolonged change in weather patterns in a particular region. Understanding these tipping points is crucial for predicting future weather patterns and mitigating the impacts of climate change. Consider also the limitations of our weather models. While these models have become increasingly sophisticated, they are still based on approximations and simplifications of the real world. They rely on vast amounts of data collected from satellites, weather stations, and other sources, but this data is never complete or perfect. There are always gaps in our knowledge and uncertainties in our measurements. Furthermore, the models themselves are based on mathematical equations that are inherently limited in their ability to capture the full complexity of the atmosphere and oceans. As a result, weather forecasts are always subject to some degree of error, particularly for longer time horizons. Now, let your mind wander to the beauty of these unpredictable patterns. Think of the swirling clouds in a hurricane, the intricate patterns of frost on a window pane, the ever-changing colors of sunset. These are all manifestations of the same underlying principles of systems dynamics and chaos. They are reminders that even in the midst of complexity and uncertainty, there is still beauty and order to be found. Embrace the unpredictability of the weather, knowing that it is a reflection of the dynamic and ever-evolving nature of our planet. As you continue to breathe deeply, let go of any need to control or understand everything. Allow yourself to simply be present in this moment, observing the world around you with a sense of curiosity and wonder. The weather will continue to unfold day after day, season after season, a constant reminder of the interconnectedness of all things. And you too are a part of this grand tapestry, connected to the earth, the sun, and the stars. Feel the gentle rhythm of your breath, the warmth of your body, and the peace of your mind. Let these sensations guide you into a deeper state of relaxation and allow yourself to drift peacefully into sleep. Sweet dreams, and may your sleep be as deep and restorative as the ocean itself. And as you drift further into relaxation, consider the fascinating interplay between order and disorder within these chaotic systems. Think about how a seemingly random event, like a single raindrop falling in a particular spot, can trigger a cascade of effects that ultimately shape the weather patterns across an entire region. This sensitivity to initial conditions, often referred to as the butterfly effect, highlights the delicate balance that exists within the Earth's climate system. It's a reminder that even the smallest actions can have far-reaching consequences, emphasizing the importance of responsible stewardship of our planet. Now, shift your focus to the vastness of the atmosphere, a swirling ocean of air that surrounds our planet, and the countless molecules of nitrogen, oxygen, and other gases constantly interacting, colliding, and exchanging energy. These interactions give rise to the winds, the clouds, and the precipitation that we experience every day. And within this dynamic system, there are patterns and structures that emerge and dissolve, constantly evolving in response to the ever-changing conditions. From the gentle breeze that rustles the leaves in a forest to the powerful jet streams that circle the globe, the atmosphere is a testament to the beauty and complexity of systems dynamics. Let your thoughts now turn to the oceans, the vast bodies of water that cover more than 70% of the Earth's surface. These oceans play a crucial role in regulating the planet's climate, absorbing heat from the sun and distributing it around the globe. Ocean currents, driven by differences in temperature and salinity, act as giant conveyor belts, transporting warm water from the equator towards the poles and cold water from the poles towards the equator. This constant circulation of water helps to moderate temperatures and create a more habitable environment for life on Earth. And just like the atmosphere, the oceans are also subject to the principles of systems dynamics and chaos, with unpredictable patterns and fluctuations that can have significant impacts on weather patterns and marine ecosystems. Think about the intricate dance between the atmosphere and the oceans, two interconnected systems that constantly interact and influence each other. The exchange of heat, moisture, and momentum between these two systems is essential for maintaining the Earth's climate balance. For example, the El Niño Southern Oscillation, ENSO, a periodic warming and cooling of the central and eastern Pacific Ocean, can have profound effects on weather patterns around the world, leading to droughts in some regions and floods in others. This complex interaction between the atmosphere and the oceans highlights the interconnectedness of all things and the importance of understanding the dynamics of these systems in order to predict and mitigate the impacts of climate change. As you continue to relax, imagine yourself floating on a cloud, drifting gently through the sky. Feel the cool air against your skin, the warmth of the sun on your face. Let go of any worries or anxieties, and simply allow yourself to be carried by the gentle currents of the atmosphere. Visualize the Earth below you, a beautiful blue planet teeming with life. Remember that you are a part of this grand system, connected to everything around you. And as you drift further into sleep, know that you are safe, secure, and loved. Let the rhythms of the Earth lull you into a peaceful slumber, and may your dreams be filled with wonder and beauty. Good night. Consider also the role of land surfaces in this intricate weather ballet. The amount of solar radiation absorbed or reflected by the land, known as albedo, significantly impacts local and regional temperatures. Forests, with their dark canopies, absorb more sunlight, leading to warmer temperatures, while deserts, with their light-colored sands, reflect more sunlight, resulting in cooler temperatures. Deforestation, urbanization, and changes in agricultural practices can all alter the Earth's albedo, leading to shifts in local and regional climate patterns. These seemingly small changes, when amplified through the complex interactions within the Earth's climate system, can contribute to larger, more unpredictable weather events. Now, let's delve a bit deeper into the concept of feedback loops, a crucial element in understanding systems dynamics and chaos. A feedback loop is a process in which the output of a system influences its own input. There are two main types of feedback loops, positive and negative. A positive feedback loop amplifies the initial change, leading to further changes in the same direction. For example, as the Earth warms, ice melts, reducing the planet's albedo and causing it to absorb even more sunlight, leading to further warming. This is a positive feedback loop that can accelerate climate change. Conversely, a negative feedback loop dampens the initial change, helping to stabilize the system. For example, as the Earth warms, more water evaporates, leading to increased cloud cover, which reflects more sunlight back into space, helping to cool the planet. This is a negative feedback loop that can help to regulate the Earth's temperature. The interplay between positive and negative feedback loops determines the overall behavior of the climate system, and their complex interactions can lead to unpredictable outcomes. Consider the example of cloud formation. Clouds play a critical role in regulating the Earth's temperature, but their behavior is incredibly complex and difficult to predict. Clouds can both reflect sunlight back into space, cooling the planet, and trap heat radiating from the Earth's surface, warming the planet. The net effect of clouds on the Earth's temperature depends on a variety of factors, including the type of cloud, its altitude, its thickness, and its location. Small changes in these factors can have significant impacts on the Earth's climate. Moreover, cloud formation is influenced by a multitude of factors, including temperature, humidity, wind patterns, and the presence of aerosols in the atmosphere. These factors interact in complex and nonlinear ways, making it challenging to predict how clouds will respond to changes in the climate. Understanding the dynamics of cloud formation is crucial for improving our ability to predict future climate change scenarios. And think about the role of aerosols, tiny particles suspended in the atmosphere. Aerosols can be natural, such as dust from deserts or sea salt from the oceans, or they could be anthropogenic, such as soot from burning fossil fuels or sulfates from industrial emissions. Aerosols can influence the Earth's climate in a variety of ways. Some aerosols, such as sulfate aerosols, reflect sunlight back into space, cooling the planet. Other aerosols, such as black carbon aerosols, absorb sunlight, warming the planet. Aerosols can also affect cloud formation, acting as cloud condensation nuclei, which are particles that water vapor can condense onto to form cloud droplets. The effects of aerosols on climate are complex and uncertain, and they're a major source of uncertainty in climate models. Now, as you continue to relax, imagine yourself standing on a mountaintop, gazing out at the vast expanse of the sky. Feel the wind in your hair, the sun on your skin. Let your mind wander and allow yourself to be captivated by the beauty and complexity of the natural world. Think about the interconnectedness of all things, the delicate balance of ecosystems, the intricate dance of weather patterns. Remember that you are a part of this grand tapestry of life, and that your actions have consequences. Strive to live in harmony with nature, to protect the environment, and to promote a sustainable future for all. As you drift further into sleep, let go of any lingering thoughts or worries. Allow yourself to be enveloped by a sense of peace and tranquility. Visualize yourself surrounded by loving and supportive people who care about you and believe in you. Know that you are worthy of love, happiness, and success. Embrace the present moment and let go of the past and the future. Trust that everything is unfolding exactly as it should. Let the gentle rhythms of your breath guide you into a deep and restful sleep. Sweet dreams. And as you consider these atmospheric complexities, let's delve a little deeper into the ocean's role. The ocean, a vast and dynamic reservoir, plays a critical role in regulating Earth's climate. It absorbs a significant amount of solar radiation, distributing heat around the globe through ocean currents. These currents, driven by differences in temperature and salinity, act as a giant conveyor belt, transporting warm water from the equator towards the poles and cold water from the poles towards the equator. This process helps to moderate temperatures and influence weather patterns worldwide. Think about the Gulf Stream, a powerful warm current in the Atlantic Ocean that brings mild temperatures to Western Europe. Without the Gulf Stream, Europe's climate would be significantly colder. The ocean also absorbs a significant amount of carbon dioxide from the atmosphere, helping to mitigate the effects of climate change. However, as the ocean absorbs more carbon dioxide, it becomes more acidic, which can have harmful effects on marine life, particularly shellfish and coral reefs. The interplay between the ocean and the atmosphere is complex and multifaceted, and it is essential to understand these interactions in order to accurately predict future climate change scenarios. Furthermore, the ocean isn't uniform. Different regions have different temperatures, salinities, and depths, all of which influence the weather patterns above. El Niño and La Niña, for example, are climate patterns in the Pacific Ocean that can have significant impacts on weather worldwide. These phenomena involve changes in sea surface temperatures in the central and eastern tropical Pacific Ocean, which can affect rainfall, temperature, and wind patterns across the globe. Now, imagine yourself floating on a raft in the middle of the ocean, feeling the gentle rocking of the waves. See the vastness of the water stretching out in all directions. Feel the warmth of the sun on your face. Let your mind drift and consider the myriad of life forms that inhabit the ocean depths, from microscopic plankton to giant whales. Think about the importance of the ocean for food, transportation, and recreation. Remember that the ocean is a precious resource that we must protect for future generations. Picture the coral reefs, vibrant ecosystems teeming with life, and consider the threats they face from pollution, climate change, and overfishing. Reflect on the importance of sustainable practices to preserve the health and biodiversity of our oceans. As you continue to relax, consider the role of land surfaces in influencing weather patterns. The Earth's land surface is incredibly diverse, ranging from towering mountains to vast plains, from dense forests to barren deserts. Each type of land surface has its own unique properties that affect the way it interacts with the atmosphere. For example, forests absorb more solar radiation than grasslands, leading to warmer temperatures in forested areas. Mountains can block airflow, creating rain shadows on the leeward side. Deserts can generate intense heat, which can lead to the formation of thunderstorms. The interaction between land surfaces and the atmosphere is complex and dynamic, and it is an important factor in determining local and regional weather patterns. Consider the impact of deforestation, which can alter rainfall patterns and increase the risk of soil erosion. Think about the importance of sustainable land management practices to maintain the health and productivity of our ecosystems. And now, as sleep deepens, imagine yourself walking through a peaceful forest, surrounded by tall trees and lush vegetation. Hear the gentle rustling of the leaves, the chirping of the birds, the babbling of a nearby stream. Feel the cool, moist air on your skin. Let your mind wander and consider the intricate web of life that connects all living things in the forest. Think about the role of trees in absorbing carbon dioxide and releasing oxygen, the importance of forests for biodiversity, and the value of these ecosystems for recreation and spiritual renewal. Remember that forests are essential for the health of our planet, and that we must protect them from deforestation, wildfires, and other threats. Visualize yourself planting a tree, contributing to the restoration of a degraded ecosystem. Feel the satisfaction of knowing that you are making a positive difference in the world. Let all thoughts fade away now, any remaining tension leaving your body, replaced by a profound sense of calm. The world outside quiets, and your inner world expands, filled with peace and serenity. The gentle rhythm of your breathing deepens, carrying you further into a state of blissful relaxation. You are safe, you are secure, you are loved. Embrace the stillness, the quiet, the darkness. Allow yourself to be carried away by the gentle currents of sleep. Let go of all worries and concerns, knowing that everything is as it should be. Surrender to the embrace of slumber and drift into a world of sweet dreams. You are at peace. You are home. Sleep well. And as you drift deeper, let's consider the role of oceans, vast and mysterious, in shaping global weather patterns. The oceans act as enormous heat reservoirs, absorbing solar radiation and distributing it around the globe through currents like the Gulf Stream. These currents transport warm water from the equator towards the poles, moderating temperatures and influencing regional climates. Think about the delicate balance within these oceanic systems. The salinity of the water, the temperature gradients, the intricate interplay of currents all contribute to the overall stability of our planet's climate. Changes in ocean temperatures, such as those associated with El Niño and La Niña, can have far-reaching effects on weather patterns across continents, leading to droughts in some regions and floods in others. Consider the impact of melting glaciers and ice sheets on ocean currents and sea levels. As these massive ice formations melt, they release fresh water into the oceans, altering salinity levels and potentially disrupting established current patterns. This, in turn, could lead to unpredictable shifts in weather patterns, affecting agriculture, ecosystems, and human societies worldwide. Visualize the immense scale of these glaciers, the ancient ice slowly yielding to the warming climate, the water flowing into the ocean, a subtle but significant change rippling through the Earth systems. Now, let your mind turn to the atmosphere itself, a dynamic and ever-changing realm. Imagine the different layers of the atmosphere, each with its unique properties and role in regulating temperature and weather. The troposphere, where we live, is where most weather phenomena occur, driven by the movement of air masses and the exchange of heat and moisture. Above that lies the stratosphere, home to the ozone layer, which protects us from harmful ultraviolet radiation. Consider the complex interactions between these layers, the flow of energy and momentum that shapes our weather. Think about the jet stream, a high-altitude wind current that steers weather systems across continents. influencing the timing and intensity of storms. Reflect on the role of atmospheric aerosols, tiny particles suspended in the air, in influencing cloud formation and precipitation. These particles can act as cloud condensation nuclei, providing a surface for water vapor to condense upon, leading to the formation of clouds and rain. The presence of aerosols can also affect the amount of sunlight that reaches the Earth's surface, influencing temperature and climate. Consider the sources of these aerosols, both natural, such as volcanic eruptions and dust storms, and anthropogenic, such as industrial emissions and burning of fossil fuels. Think about the impact of air pollution on weather patterns and human health, and the importance of reducing emissions to improve air quality and protect our planet. As you continue to relax, visualize the Earth as a complex, interconnected system where everything is linked and interdependent. The atmosphere, the oceans, the land, and the biosphere all interact in intricate ways, shaping our planet's climate and weather. Small changes in one part of the system can have cascading effects on other parts, leading to unpredictable outcomes. This is the essence of chaos theory, the idea that even deterministic systems can exhibit unpredictable behavior due to their sensitivity to initial conditions. Appreciate the beauty and complexity of this system, the delicate balance that sustains life on Earth. Let all these thoughts gently fade away, like clouds drifting across the sky. Your mind is calm, your body is relaxed, and you are ready to drift into a deep and restful sleep. The gentle rhythm of your breathing carries you further into a state of tranquility. You are safe, you are secure, you are loved. Embrace the stillness, the quiet, the darkness. Allow yourself to be carried away by the gentle currents of sleep. Let go of all worries and concerns, knowing that everything is as it should be. Surrender to the embrace of slumber and drift into a world of sweet dreams. You are at peace. You are home. Sleep well. And now, as your mind continues to quiet, let's consider the role of feedback loops in this intricate dance of weather and climate. Imagine a scenario where rising temperatures lead to the melting of ice caps and glaciers. This melting, in turn, reduces the Earth's albedo, its reflectivity, causing the planet to absorb even more solar radiation. This increased absorption further accelerates the warming trend, creating a positive feedback loop. It's a cycle where an initial change amplifies itself, leading to potentially dramatic shifts in the climate system. Other examples abound. The release of methane from thawing permafrost, the changing patterns of ocean currents, and the intricate interplay between vegetation and rainfall. These feedback loops, both positive and negative, are constantly at work, shaping the trajectory of our climate and influencing the weather patterns we experience every day. Understanding these intricate connections is crucial for predicting future climate scenarios and mitigating the impacts of human activities on the environment. Now, think about the concept of tipping points. These are critical thresholds in the Earth's climate system beyond which significant and potentially irreversible changes occur. Imagine a stack of dominoes. Each domino represents a component of the climate system. and when one domino falls, it triggers a cascade of others. The collapse of a major ice sheet, the dieback of a vast forest, or the acidification of the oceans. These are all examples of potential tipping points that could have profound consequences for the planet. The challenge lies in identifying these tipping points before they are reached and taking action to prevent them from being triggered. This requires a deep understanding of the complex interactions within the Earth system and a commitment to sustainable practices that reduce our impact on the environment. It also calls for international cooperation and a willingness to embrace innovative solutions to address the climate crisis. As you settle even deeper into relaxation, let's consider the role of human ingenuity in understanding and predicting weather patterns. Think about the sophisticated computer models that scientists use to simulate the atmosphere and oceans, incorporating vast amounts of data from satellites, weather stations, and other sources. These models are constantly being refined and improved, allowing us to make more accurate forecasts and better understand the complexities of the climate system. Consider the challenges of modeling chaos, of capturing the full range of possible outcomes given the inherent uncertainty in the system. Think about the ethical considerations involved in using climate models to inform policy decisions, and the importance of communicating scientific findings clearly and effectively to the public. Human understanding, coupled with technological advancement, provides us with the best chance to navigate the challenges of a changing climate. And now, as you prepare to fully surrender to sleep, imagine yourself floating on a gentle cloud, carried by the softest breeze. Feel the warmth of the sun on your skin, the coolness of the air around you. Let all thoughts of weather patterns and climate models drift away, replaced by a sense of peace and tranquility. You are safe, you are secure, you are loved. The world is beautiful, and you are part of it. Embrace the stillness, the quiet, the darkness. Allow yourself to be carried away by the gentle currents of sleep. Let go of all worries and concerns, knowing that everything is as it should be. Surrender to the embrace of slumber and drift into a world of sweet dreams. You are at peace. You are home. Sleep well as you drift even further into this state of peaceful awareness. Let's turn our attention to the beauty and resilience of nature itself. Consider the intricate ways in which ecosystems adapt to changing weather patterns. Think of the forests that withstand fierce storms, the deserts that bloom after rare rainfall, the coral reefs that slowly recover from bleaching events. These natural systems are incredibly complex and interconnected, each playing a vital role in maintaining the balance of the planet. Reflect on the power of natural selection, the way in which species evolve over time to better cope with the challenges of their environment. Marvel at the ingenuity of nature, the endless creativity that shapes the world around us. Even within the unpredictable dance of weather, there is an underlying order, a deep harmony that connects all living things. Now, as your mind grows quieter and your body more relaxed, let's contemplate the concept of interconnectedness. Every action we take, every choice we make, has ripple effects that extend far beyond our immediate surroundings. the way we consume resources, the way we treat the environment, the way we interact with each other. All of these things contribute to the overall health and well-being of the planet. Consider the importance of mindful living, of being aware of the impact of our actions, and striving to make choices that are sustainable and compassionate. Think about the power of collective action, the ability of people to come together to create positive change in the world. By working together, we can build a more resilient and equitable future for all. And as you feel yourself sinking deeper and deeper into slumber, let's appreciate the simple joys of life. The warmth of a sunny day, the sound of rain on the roof, the smell of freshly cut grass, the sight of a rainbow after a storm. These are the moments that make life worth living. Let these simple pleasures fill your heart with gratitude and joy. Remember that even in the midst of chaos and uncertainty, there's always beauty to be found. Open your senses to the wonders of the world around you and allow yourself to be filled with awe and wonder. Feel the weight of your body melting away, your muscles relaxing, your breath becoming slow and deep. Let go of any remaining tension or stress and allow yourself to be completely present in this moment. You are safe, you are secure, you are loved. The universe is vast and mysterious, but you are an integral part of it. Embrace your connection to all things and allow yourself to be carried away by the gentle currents of sleep. Surrender to the embrace of slumber and drift into a world of sweet dreams. You are at peace. You are home. Sleep well, and may your dreams be filled with wonder and tranquility. And as you drift further into that peaceful state, let's consider the beauty of patterns, not just in weather, but in all of nature. Think of the intricate fractal patterns of a snowflake, each one unique, yet formed by the same simple rules of water molecules freezing, or the swirling patterns of a galaxy, billions of stars held together by gravity, forming vast, majestic structures. These patterns remind us that even within complexity, there's an underlying order, a fundamental elegance that governs the universe. Consider the Fibonacci sequence, a mathematical pattern that appears in the arrangement of petals on a flower, the spirals of a seashell, and even the branching of trees. It's a testament to the inherent mathematical harmony that exists in the natural world, a reminder that even seemingly random events can be guided by deeper principles. Now let your mind wander to the idea of emergence. How complex systems arise from simple interactions. Think about a flock of birds, each individual bird following a few simple rules. Stay close to your neighbors, avoid obstacles. Yet collectively, they create breathtaking aerial displays, swirling and changing direction in perfect unison. This is emergence in action, a beautiful example of how order can arise from chaos, how complex behavior can emerge from simple rules. Consider the human brain, a network of billions of neurons, each one a simple cell. Yet collectively, they create consciousness, allowing us to think, feel, and experience the world around us. It's a profound mystery how such complexity can arise from such simplicity, a testament to the power of emergence. And as you feel your body growing heavier, your mind more still, let's reflect on the concept of resilience. Just as weather systems can adapt and recover from disturbances, so too can we. Life is full of challenges, of storms that threaten to knock us off course. But we have the capacity to adapt, to learn, and to grow from these experiences. Think about the trees that bend in the wind, their roots firmly planted in the ground, weathering the storm. They remind us that resilience is not about avoiding challenges, but about developing the strength and flexibility to overcome them. Consider the human spirit, our ability to persevere in the face of adversity, to find hope even in the darkest of times. It's a testament to our innate resilience, our ability to bounce back from setbacks and emerge stronger than before. So, let these thoughts of patterns, emergence, and resilience soothe your mind and carry you deeper into sleep. Know that you are part of a vast and interconnected web of life, that you are capable of great resilience, and that even in the midst of chaos, there is beauty and order to be found. Allow yourself to be filled with a sense of peace and tranquility, knowing that you are safe, you are loved, and you are home. Let go of any worries or anxieties and surrender to the gentle embrace of sleep. Drift into a world of dreams where anything is possible, where the boundaries of reality blur, and where your imagination can soar. Sleep deeply, sleep peacefully, and wake up refreshed and renewed. Good night. As you drift further into slumber, let's contemplate the idea of feedback loops, a crucial element in understanding complex systems like our weather and even our own lives. Imagine a thermostat in your home. When the temperature drops below a certain point, the thermostat sends a signal to the heater to turn on. As the room warms up, the thermostat senses the change and eventually signals the heater to turn off. This is a negative feedback loop, a self-regulating mechanism that helps maintain stability. Now consider a positive feedback loop. Think of a snowball rolling down a hill. As it gathers more snow, it becomes larger and faster, gathering even more snow, creating a runaway effect. In weather systems, positive feedback loops can amplify small changes, leading to dramatic shifts in temperature, precipitation, or wind patterns. The melting of Arctic ice, for example, is a positive feedback loop. As ice melts, it exposes darker ocean water, which absorbs more sunlight, leading to further warming and more ice melt. These feedback loops, both positive and negative, are constantly interacting, shaping the behavior of complex systems and contributing to their inherent unpredictability. And as your breath grows deeper and your thoughts more serene, let's turn our attention to the concept of fractals. Look closely at a snowflake. You'll notice that it's made up of smaller, repeating patterns, each one resembling the larger whole. This is a fractal, a geometric shape that exhibits self-similarity at different scales. Fractals are found throughout nature, from the branching of trees to the patterns of coastlines to the distribution of galaxies in the universe. They are a visual reminder that complexity can arise from simple rules, that order and beauty can be found even in the most chaotic systems. Consider the patterns of lightning strikes, each one a unique and intricate fractal, or the swirling patterns of clouds in a hurricane. These natural fractals are testaments to the underlying mathematical structures that govern the world around us, revealing a hidden order within apparent chaos. Think about the veins in a leaf, mirroring the branching of a river system, each a fractal design optimizing the flow of resources. This efficiency, this inherent design woven into the fabric of reality, is both elegant and profound. It suggests a deep interconnectedness, a universal language spoken by nature itself. And as you listen to the gentle rhythm of your breath, consider how these fractal patterns extend beyond the physical world, influencing our thoughts, our emotions, and our relationships. The way we make decisions, the way we interact with others, the way we experience the world, all are shaped by complex patterns of feedback and influence, fractal reflections of the larger systems in which we are embedded. So, let these images of feedback loops and fractals wash over you, soothing your mind and preparing you for sleep. Embrace the beauty of complexity, the mystery of emergence, and the resilience of life. Know that you are a part of this intricate dance, a unique and valuable piece of the puzzle. Release any tension you may be holding and allow yourself to drift into the realm of dreams, where the boundaries of reality dissolve and the imagination takes flight. Sleep soundly, sleep deeply, and wake up refreshed and ready to embrace the day. May your dreams be filled with wonder and peace. Sweet dreams that as you settle deeper into relaxation, let's consider the concept of emergence, a key principle in systems dynamics. Emergence describes how complex patterns and behaviors arise from the interactions of simpler components. Think of a flock of birds, each individual following simple rules of proximity and alignment, yet collectively creating breathtaking aerial displays of coordinated movement. No single bird is directing the flock. The flock's behavior emerges from the interactions of all the individuals. Similarly, consciousness itself could be considered an emergent property of the complex interactions within the brain, a symphony of neurons firing in concert to create the subjective experience of being. Weather patterns, too, are a prime example of emergence. Countless individual molecules of air and water, each governed by the laws of physics, interact in ways that give rise to vast, swirling storms, gentle breezes, and everything in between. Predicting these emergent behaviors with perfect accuracy is an immense challenge, as even tiny variations in initial conditions can cascade through the system, leading to dramatically different outcomes. This sensitivity to initial conditions is often referred to as the butterfly effect, the idea that the flap of a butterfly's wings in Brazil could theoretically set off a tornado in Texas. While the butterfly effect is often oversimplified, it captures the essence of how small, seemingly insignificant changes can amplify over time in complex systems. Consider the flow of water in a river. Each drop of water is simply responding to gravity and the contours of the riverbed. Yet, collectively, these drops carve out intricate channels, form eddies and rapids, and create a dynamic and ever-changing landscape. The river's overall behavior is more than just the sum of its individual parts. It is an emergent property of the entire system, shaped by feedback loops between the water, the land, and even the vegetation along its banks. These feedback loops can either amplify or dampen changes, creating a delicate balance that is constantly being renegotiated. A small change in rainfall, for instance, can lead to changes in erosion patterns, which in turn can alter the course of the river itself. Now, visualize yourself as a part of an even larger system, a vast network of interconnected individuals, communities, and ecosystems. Just as the weather is influenced by countless factors, your own life is shaped by a multitude of influences, some obvious and some subtle. The choices you make, the people you interact with, the information you consume, all contribute to the complex tapestry of your life. And just as the weather is inherently unpredictable, so too is the future. Embrace the uncertainty, knowing that you have the power to influence the system in positive ways, even if the ultimate outcome remains unknown. Focus on cultivating positive feedback loops in your own life. Acts of kindness, moments of gratitude, and a commitment to personal growth. These small actions can ripple outward, creating positive change in the world around you. As you drift further into sleep, remember that even chaos has its own inherent order. The universe is constantly creating and destroying, organizing and reorganizing. And within this dynamic process lies the potential for endless beauty and innovation. Trust in the underlying intelligence of the universe and allow yourself to surrender to the flow of life. Let go of any anxieties or worries you may be holding on to, and embrace the peace and tranquility of this moment. Feel the gentle rhythm of your breath, the warmth of your body, and the comforting darkness that surrounds you. You are safe, you are loved, and you are a vital part of this magnificent universe. Allow yourself to drift deeper and deeper into sleep, knowing that you will wake up refreshed and renewed, ready to embrace the day with a sense of wonder and gratitude. Sweet dreams, and may your sleep be filled with peace and restorative rest. And as you breathe in and out, consider the concept of strange attractors within these chaotic systems. Think of them as patterns that emerge from seeming randomness, subtle pathways that the system tends to gravitate toward, without ever quite repeating itself exactly. In weather, a strange attractor might represent a recurring seasonal pattern, like the monsoon season in India or the El Niño phenomenon in the Pacific. These are not predictable in their exact timing or intensity, but they represent a broad tendency of the system to behave in a certain way. Your own life, too, has its strange attractors, habits, relationships, or aspirations that pull you in certain directions, shaping your experiences and influencing your decisions. Recognizing these attractors can give you a sense of agency, allowing you to consciously choose whether to follow their path or to forge a new one. Now, let's explore the idea of scale invariance, a fascinating characteristic of chaotic systems. Scale invariance means that patterns repeat themselves at different levels of magnification. Think of a coastline. From far away, it appears as a jagged line, but as you zoom in, you see smaller and smaller indentations and peninsulas that resemble the larger pattern. This same principle applies to weather patterns. A hurricane, for example, has a swirling structure that is similar to the eddies in a stream or even the spiral arms of a galaxy. This interconnectedness of scales is a reminder that everything in the universe is related, that the small and the large are inextricably linked. Consider how your own actions, seemingly insignificant in the grand scheme of things, can have far-reaching consequences, rippling outwards to affect the lives of others. Every act of kindness, every word of encouragement, every conscious choice to do good contributes to a larger pattern of positive change. And as your mind continues to wander, consider the limitations of our understanding. Despite our best efforts to model and predict chaotic systems, there will always be an element of uncertainty. This is not a cause for despair, but rather a call for humility and a reminder to embrace the unknown. The beauty of the universe lies not just in what we know, but also in what we don't know, in the mysteries that continue to beckon us forward. Just as weather forecasters can only provide probabilities, not certainties, so too must we approach life with a sense of openness and flexibility, ready to adapt to whatever comes our way. Allow yourself to release the need for control, to surrender to the inherent unpredictability of life, and to trust that you have the inner resources to navigate whatever challenges may arise. So, as you continue to relax and let go, remember the power of observation and the beauty of complexity. The weather, with its intricate dance of forces, is a constant reminder of the interconnectedness of all things. Your own life, with its unique tapestry of experiences, is a testament to the resilience and adaptability of the human spirit. Embrace the chaos, knowing that within it lies the potential for growth, innovation, and profound beauty. Let the calming rhythm of your breath guide you deeper into sleep, and allow yourself to be carried away on a gentle current of peace and tranquility. Release all tension from your body and feel yourself becoming lighter and lighter, floating effortlessly in the darkness. You are safe, you are supported, and you are deeply loved. Allow the soothing sounds of silence to wash over you, and drift gently into a world of sweet dreams and restorative rest. Sleep well, and may your night be filled with peace. And as you drift further into slumber, consider the concept of emergence. How simple rules and interactions can give rise to incredibly complex and beautiful patterns. Think of snowflakes, each one unique, yet formed by the same basic principles of water molecules arranging themselves according to temperature and humidity. Or consider the flocking behavior of birds, seemingly coordinated, yet driven by each bird simply following a few local rules about staying close to its neighbors and avoiding obstacles. These emergent phenomena remind us that order can arise from chaos, and that even in the absence of central control, intricate and harmonious systems can self-organize. Your own body is a testament to this principle, a collection of trillions of cells working in concert, each with its own function, yet all contributing to the overall health and well-being of the organism. Trust in the wisdom of your body, its ability to heal and regenerate, to adapt and overcome challenges. Now, let your thoughts turn to the power of feedback loops, the mechanisms by which systems regulate themselves and maintain stability. Imagine a thermostat controlling the temperature of a room, constantly monitoring the environment and adjusting the heating or cooling system accordingly. Or consider the intricate feedback loops that govern your own physiology, maintaining your body temperature, blood pressure, and hormone levels within narrow ranges. These feedback loops are essential for maintaining equilibrium, but they can also be sources of instability. Positive feedback loops, in particular, can amplify small changes and lead to runaway effects, as seen in the greenhouse effect, where increasing temperatures lead to more greenhouse gas emissions, which in turn lead to even higher temperatures. As you drift off to sleep, appreciate the delicate balance of these feedback loops and the importance of understanding their potential impacts on the systems around us. And as you continue to relax, reflect on the interconnectedness of all things, the way in which even seemingly isolated events can have far-reaching consequences. The butterfly effect, while often oversimplified, captures the essence of this principle, reminding us that small changes in one part of the system can propagate and amplify, leading to unpredictable outcomes in other parts of the system. This interconnectedness extends beyond the physical world, encompassing our relationships, our communities, and our planet as a whole. Every action we take, every decision we make, has an impact on the world around us, however small it may seem. So, as you fall asleep, commit to acting with intention, to making choices that promote well-being and sustainability, and to recognizing the profound interconnectedness of all life. Breathe deeply and let go of any remaining tension or worry. Visualize yourself surrounded by a warm, comforting light, a protective shield that deflects negativity and promotes healing. Feel the gentle rhythm of your breath, a constant reminder of the life force that flows through you. You are connected to something larger than yourself, a vast and intricate web of energy and consciousness. Trust in the universe to guide you, to support you, and to provide you with everything you need. Allow yourself to surrender to the present moment, to let go of the past and the future, and to simply be. You are safe, you are loved, and you are at peace. Now, as you approach the threshold of sleep, consider the infinite possibilities that lie within your subconscious mind. Your dreams are a gateway to another world, a realm of symbols and metaphors, where deepest desires and fears can be explored and processed. Embrace the power of your dreams and allow them to guide you on your journey of self-discovery. Know that you are capable of anything you set your mind to, and that you have the strength and resilience to overcome any obstacle. As you drift off to sleep, repeat to yourself, I am strong, I am capable, I am loved. Let the gentle waves of relaxation wash over you, carrying you deeper and deeper into slumber. Feel your body becoming heavy and relaxed, your mind becoming quiet and still. You are safe, you are supported, and you are deeply loved. Allow the soothing sounds of silence to fill your awareness and drift gently into a world of sweet dreams and restorative rest. Sleep well, and may your night be filled with peace, tranquility, and profound healing. Good night. And as you gently transition into the realm of slumber, let's consider the fascinating interplay of order and chaos, not just in weather patterns, but within ourselves. Think about your own internal systems, the intricate dance of hormones, neurotransmitters, and countless other biological processes that keep you functioning, breathing, and dreaming. These systems, much like the weather, are incredibly complex and sensitive to initial conditions. A small change in diet, a stressful event, or even a shift in your sleep schedule can ripple through your internal landscape, leading to noticeable shifts in your mood, energy levels, and overall well-being. Just as meteorologists use sophisticated models to predict the weather, we can also develop a deeper understanding of our own internal systems through mindfulness, self-awareness, and healthy habits. By paying attention to the subtle signals our bodies send us, we can learn to anticipate potential imbalances and take proactive steps to restore equilibrium. This might involve adjusting our diet, practicing relaxation techniques, or seeking support from loved ones or professionals. The key is to recognize that we are not simply passive recipients of our internal weather, but active participants in shaping our own well-being. Consider the power of positive self-talk, for example. Just as a small change in atmospheric pressure can trigger a chain reaction that leads to a major storm, a single negative thought can spiral into a cascade of anxiety and self-doubt. Conversely, a conscious effort to cultivate positive thoughts and affirmations can create a ripple effect of optimism and resilience, helping us to navigate the inevitable challenges of life with greater ease and grace. Think of these positive affirmations as tiny seeds of hope that you plant in the fertile ground of your subconscious mind. With consistent nurturing, these seeds can blossom into a vibrant garden of self-belief and inner peace. As you drift further into sleep, imagine yourself as a skilled navigator, charting your course through the unpredictable seas of life. You have the tools and the wisdom to steer your ship through storms and navigate towards calmer waters. Trust in your inner compass, your intuition, and your ability to adapt to changing conditions. Remember that even the most turbulent weather eventually subsides, and that every storm is an opportunity for growth and transformation. Embrace the uncertainty of life, knowing that you have the strength and resilience to weather any challenge that comes your way. Now, let your mind wander to the beauty and wonder of the natural world. Think about the intricate patterns of snowflakes, the mesmerizing swirls of galaxies, and the delicate balance of ecosystems. All of these phenomena are governed by the same fundamental principles of systems dynamics and chaos that shape our weather patterns. They remind us that everything is interconnected, that every action has a consequence, and that even the smallest things can have a profound impact on the whole. As you contemplate these interconnectedness, feel a sense of gratitude for the abundance and beauty that surrounds you. And as you finally surrender to the embrace of sleep, know that you are part of something vast and magnificent, a universe of infinite possibilities. You are a unique and valuable expression of this universe, and your presence makes a difference. Rest deeply, knowing that you are loved, supported, and always connected to the source of all creation. Allow yourself to drift into a world of peaceful dreams, where anything is possible and where your imagination can soar. Sleep soundly and awaken refreshed and renewed, ready to embrace the day with joy and purpose. Good night. Now, consider the concept of fractals, those infinitely complex patterns that repeat themselves at different scales. Think of a coastline, jagged and uneven, or the branching of a tree, each branch mirroring the structure of the whole. These fractals are visual representations of chaos and systems dynamics in action. They illustrate how simple rules, when applied repeatedly, can generate incredibly intricate and unpredictable forms. The weather itself is full of fractal patterns, from the swirling clouds in a hurricane to the intricate paths of lightning bolts. As you visualize these patterns, let them remind you of the beauty and complexity that exists within apparent disorder. Let them also remind you that within yourself, there are layers upon layers of potential waiting to be explored and unfolded. As you breathe deeply and evenly, imagine yourself floating among these fractal patterns, becoming one with the interconnected web of life. Feel the gentle currents of energy flowing through you, connecting you to everything around you. Release any tension or stress that you may be holding on to, allowing it to dissolve into the vastness of the universe. You are safe, you are supported, and you're loved. Let go of any worries or anxieties about the future and simply be present in this moment. This moment is all that truly exists, and in this moment, you are perfect, whole, and complete. Think about the butterfly effect, the idea that a butterfly flapping its wings in Brazil could theoretically set off a tornado in Texas. While this is a simplified illustration, it captures the essence of sensitive dependence on initial conditions. It highlights how seemingly insignificant events can have far-reaching consequences in complex systems. In our own lives, small acts of kindness, compassion, and self-care can ripple outwards, creating positive change in the world around us. Similarly, negative thoughts and actions can have unintended consequences that affect not only ourselves, but also those around us. Be mindful of the choices you make, knowing that even the smallest actions can have significant impact. Now, let your thoughts turn to the power of feedback loops, those self-regulating mechanisms that can either amplify or dampen changes in a system. Positive feedback loops reinforce a trend, leading to exponential growth or decline. Think of a snowball rolling down a hill. gathering more snow and increasing in size as it goes. Negative feedback loops, on the other hand, work to stabilize a system, preventing it from spiraling out of control. Think of a thermostat, which regulates the temperature of a room by turning the heating or cooling system on and off as needed. Both positive and negative feedback loops play a crucial role in shaping the dynamics of complex systems, including the weather and our own lives. Recognize the feedback loops that are operating in your own life, and consciously choose to cultivate those that support your well-being and growth. As you continue to relax and drift deeper into sleep, consider the concept of emergence, the idea that complex patterns and behaviors can arise spontaneously from the interactions of simple components. Think of a flock of birds, which can perform intricate aerial maneuvers without any central coordination. Each bird simply follows a few basic rules, such as staying close to its neighbors and avoiding collisions. Yet, collectively, the flock exhibits emergent behaviors that are far more complex than the rules followed by any individual bird. Similarly, our own consciousness may be an emergent property of the complex interactions between billions of neurons in our brains. Embrace the mystery and wonder of emergence, recognizing that the whole is often greater than the sum of its parts. And as you embrace this mystery, know that you too are capable of amazing things, far beyond what you may currently imagine. And finally, as you succumb to the comforting embrace of slumber, remember that you are a part of this intricate dance of systems, dynamics, and chaos. You are a vital component of a universe, and your presence matters. Allow yourself to be carried away by the gentle currents of sleep, knowing that you are safe, loved, and supported. Trust in the wisdom of your subconscious mind to guide you through the night, and awaken refreshed and renewed, ready to embrace the beauty and wonder of a new day. Sweet dreams. Now, let's gently turn our attention to the fascinating realm of fractals. Fractals are infinitely complex patterns that are self-similar across different scales. Think of a snowflake, a fern, or the branching of a river. Each part, when magnified, resembles the whole. Fractals are not just beautiful mathematical curiosities. They are ubiquitous in nature, reflecting the underlying principles of systems dynamics and chaos. They demonstrate how simple rules, repeated iteratively, can generate incredibly intricate and complex forms. The coastline, for example, is a fractal. Zoom in, and you'll find smaller bays and inlets that mirror the larger shape of the coast. Our lungs, too, are fractal structures, maximizing surface area for efficient gas exchange. Meditating on fractals can offer a glimpse into the interconnectedness of all things, reminding us that even the smallest details can contain the essence of the whole. As you breathe deeply, visualize a fractal pattern and allow its intricate beauty to soothe your mind and relax your body. Consider, too, the concept of strange attractors. In chaotic systems, trajectories may seem random and unpredictable, but they are often confined to a specific region of phase space called strange attractor. Imagine a pendulum swinging erratically, never quite repeating the same motion. Its path, while chaotic, is still bounded by the attractor, a kind of invisible force field that shapes its behavior. Strange attractors are like cosmic dance floors, where systems twirl and sway in a perpetual state of dynamic equilibrium. The weather, with its swirling storms and shifting patterns, is governed by a strange attractor, a complex interplay of temperature, pressure, and humidity. As you drift off to sleep, imagine yourself floating within a strange attractor, a space of infinite possibilities, where order and chaos coexist in perfect harmony. Feel the gentle pull of this attractor, guiding you toward a state of deep relaxation and restful sleep. And let's not forget the vital role of initial conditions. The butterfly effect, a well-known concept in chaos theory, illustrates how small changes in initial conditions can lead to dramatically different outcomes. A butterfly flapping its wings in Brazil, it is said, could theoretically set off a tornado in Texas. While this is a metaphorical illustration, it highlights the profound sensitivity of chaotic systems to even the tiniest perturbations. In weather forecasting, even the most sophisticated models can be thrown off by slight inaccuracies in initial data. This underscores the inherent limitations of prediction in complex systems, but it also emphasizes the importance of attention to detail. In our own lives, small choices and actions can have far-reaching consequences, shaping our destinies in ways we may never fully comprehend. As you prepare to sleep, reflect on the power of initial conditions and consciously choose to set positive intentions for the day ahead. Let your thoughts and actions be guided by compassion, kindness, and a deep appreciation for the interconnectedness of all things. Finally, as sleep gently claims you, remember that the universe is a vast and intricate web of interconnected systems, constantly evolving and adapting. You are an integral part of this web, a vital node in the network of life. Embrace the uncertainty and unpredictability of the world, knowing that chaos and order are not opposing forces, but rather two sides of the same coin. Surrender to the flow of life, trusting that you are exactly where you need to be at this very moment. Let go of any worries or anxieties and allow yourself to be carried away by the gentle currents of sleep. Know that you are loved, supported, and deeply connected to the universe. Sleep soundly and awaken refreshed, renewed, and ready to embrace the beauty and wonder of a new day. Good night. And as you drift further into slumber, consider the concept of feedback loops, another crucial element in understanding systems dynamics. Positive feedback loops amplify change, accelerating a process in one direction. Think of melting ice caps. As ice melts, less sunlight is reflected back into space, leading to further warming and even more melting. This creates a self-reinforcing cycle, pushing the system towards a new, potentially unstable state. Negative feedback loops, on the other hand, act as stabilizers, counteracting change and maintaining equilibrium. A thermostat, for example, uses negative feedback to regulate temperature, turning on the heat when it gets too cold and turning it off when it gets too warm. These loops, constantly interacting and influencing each other, are what give weather systems their dynamic and often unpredictable nature. Understanding these feedback mechanisms can help us appreciate the intricate dance of cause and effect that shapes our world, both in the atmosphere and in our own lives. Now, let your mind wander to the fascinating world of fractals. These intricate, self-similar patterns appear throughout nature, from the branching of trees to the formation of snowflakes and, yes, even in the swirling patterns of clouds. Fractals are a visual representation of chaos, demonstrating how simple rules can generate complex and beautiful structures. The coastline, with its endless bays and peninsulas, is a classic example of a fractal pattern. Zoom in on any section of the coast, and you'll find the same level of detail and complexity as you would at a larger scale. This self-similarity is a hallmark of chaotic systems, reflecting the interconnectedness of scales and the way small patterns can cascade into larger, more complex forms. As you visualize these fractal patterns, allow their intricate beauty to soothe your mind and ease you into a deeper state of relaxation. Think also of the role of energy in these systems. The sun, our primary source of energy, drives all weather phenomena. Uneven heating of the Earth's surface creates temperature gradients, which in turn drive winds and ocean currents. This energy is constantly being transferred and transformed, creating a dynamic and ever-changing system. The atmosphere acts as a giant heat engine, converting solar energy into kinetic energy in the form of winds and storms. Understanding the flow of energy through these systems is essential for comprehending their behavior. And just as energy flows through the atmosphere, it also flows through our own bodies and minds. As you sleep, allow your body to recharge and replenish its energy reserves, preparing you for the challenges and opportunities of the day ahead. And as your thoughts begin to fade, consider the broader implications of systems dynamics and chaos theory. These concepts are not limited to weather patterns. They apply to a wide range of complex systems, from financial markets to ecosystems to even our own brains. Understanding the principles of chaos and complexity can help us navigate the uncertainties of life with greater resilience and adaptability. It can also foster a deeper appreciation for the interconnectedness of all things and the importance of embracing change. So, as you drift off to sleep, remember that you are part of a vast and dynamic system, constantly evolving and adapting. Embrace the uncertainty, trust in the process, and allow yourself to be carried away by the gentle currents of sleep, knowing that you are exactly where you need to be at this very moment. Sleep well. Now let's delve a bit deeper into the concept of feedback loops within these complex weather systems. Imagine a small patch of ocean that warms slightly due to increased solar radiation. This warmer water evaporates more readily, leading to increased humidity in the air above. That humid air can then rise and form clouds. Now, depending on the type of clouds that form, there can be different effects. High, Wispy cirrus clouds can actually trap heat, further warming the surface, creating a positive feedback loop. Conversely, low, thick stratus clouds can reflect sunlight back into space, cooling the surface and creating a negative feedback loop. These feedback loops, both positive and negative, are constantly interacting and influencing the overall behavior of the weather system. It's this intricate dance of opposing forces that contributes to the unpredictable nature of weather. Consider also the role of the Earth's rotation, the Coriolis effect, which deflects moving air and water, creating swirling patterns of winds and ocean currents. This effect is responsible for the formation of large-scale weather systems like cyclones and anticyclones. The Coriolis effect is strongest at the poles and weakest at the equator, leading to different weather patterns in different regions of the world. These large-scale patterns then interact with smaller-scale features like mountains and coastlines, creating even more complex and localized weather phenomena. Visualize the Earth spinning slowly beneath you, the atmosphere swirling around it like a vast, fluid ocean. See the interplay of forces, the energy flowing, the constant change and adaptation. Think about the predictability of weather forecasts. While we've made tremendous strides in weather prediction over the past few decades, thanks to advancements in computing power and satellite technology, there are still inherent limitations. The chaotic nature of the atmosphere means that even the smallest errors in initial conditions can grow exponentially over time, leading to significant deviations in the forecast. This is often referred to as the butterfly effect, where the flapping of a butterfly's wings in Brazil could theoretically set off a tornado in Texas. While the butterfly effect is a somewhat exaggerated illustration, it highlights the sensitivity of chaotic systems to initial conditions. Weather models are incredibly complex, incorporating vast amounts of data from various sources, but they are still simplifications of reality. They can't possibly capture every single detail of the atmosphere, and those missing details can sometimes have a significant impact on the accuracy of the forecast. So, while we can often predict the weather with reasonable accuracy for a few days out, the longer-term forecasts become increasingly uncertain. It's a reminder that even with our best efforts to understand and predict the world around us, there will always be an element of uncertainty. Now, let's consider the impact of climate change on these weather patterns. As the Earth's climate warms, due to increased greenhouse gas emissions, we're seeing changes in the frequency and intensity of extreme weather events. Heat waves are becoming more frequent and severe, droughts are lasting longer, and heavy rainfall events are becoming more intense. These changes are not just random fluctuations. They're a consequence of the altered energy balance of the planet. A warmer atmosphere can hold more moisture, which can lead to heavier rainfall. Warmer ocean temperatures can fuel stronger hurricanes. And changes in atmospheric circulation patterns can lead to prolonged droughts in some regions. Understanding the complex interplay between climate change and weather patterns is crucial for preparing for the challenges of the future. We need to develop strategies to mitigate the effects of climate change and adapt to the changing weather patterns we are already experiencing. As you drift further into sleep, consider the responsibility We all share in protecting our planet and ensuring a sustainable future for generations to come. Imagine the Earth as a delicate and interconnected system, and visualize the positive changes we can make to restore balance and harmony. And as you prepare to surrender completely to sleep, remember that even in the midst of chaos and uncertainty, there is also order and beauty. The patterns of weather, like the patterns of life, are constantly evolving and adapting. Embrace the unknown, trust in the natural processes, and allow yourself to be carried away by the gentle rhythm of your breath. Each inhale and exhale is a reminder of your connection to the vast and dynamic system of life. Surrender to the present moment. Let go of any worries or anxieties, and allow yourself to be enveloped in a sense of peace and tranquility. Sleep deeply, knowing that you are safe, secure, and loved. Let your mind wander through the landscapes of your dreams, exploring new possibilities and discovering hidden truths. And when you awaken, may you be refreshed, rejuvenated, and ready to embrace the day with renewed energy and enthusiasm. Sweet dreams.